এটা কার নাম্বার?
এটা হচ্ছে মামুনের নাম্বার। মামুন, আমার অ্যাসিস্ট্যান্ট মামুন, ওর নাম্বার হচ্ছে 01631 481 811 0163 148 1811। হ্যাঁ ঠিক আছে। অলরাইট, আচ্ছা এটাতে কল দিলে পাই যাওয়া। ঠিক আছে, উই স্টার্ট দ্য রেকর্ডিং, সো আই এম গোনা জাম্প ইনটু দ্য কোশ্চেন। আচ্ছা
স্যার অনেকগুলো রেকর্ডিং মানে দেওয়া হয়নি স্যার ইউটিউব।
আরে আচ্ছা, এগুলো আজকে রাতে আপলোড করব।
আচ্ছা স্যার।
আই এম রিয়েলি ল্যাগিং বিহাইন্ড। I'll upload them. আচ্ছা, শুভ যে কোশ্চেনগুলো দিয়েছিলাম সেই কোশ্চেনগুলো শুরু করতেছি। আপাতত আমি মেসেঞ্জার চ্যাটটা নামায় রাখলাম কারণ আমার এখানে অ্যাক্সেস করা দরকার। সো দিস ইজ দ্য থিং, দিস ইজ দ্য A2 ওয়ার্কশিট, বুকলেট 2, ইলেক্ট্রোম্যাগনেটিজম ওয়ার্কশিট, মার্ক স্কিম। কি হলো? এটা লাগবে না। সো শুভ্র আমাদেরকে প্রবলেম দিছে হচ্ছে, বললাম প্রবলেম যাই লেখো না কেন অল চ্যাটে লেখো, ডোন্ট সেন্ড মি ডিরেক্টলি। কোশ্চেন নাম্বার 11। হ্যাঁ পাইছি, শুভ্র বলো এখানে কোথায় কোথায় সমস্যা?
স্যার 11 মানে গ্রাফগুলো একটু এক্সপ্লেন করা লাগতো।
Asha, 11 number graphs are actually really simple. I'll help you to understand this. Have a look. We have a magnetic flux intensity that has a value of B. This is the current that is flowing by. So the equation that actually relates all of these variables for magnetic force is given by thickness. Okay, F equals to BIL sin theta. Now, the thing that you have to understand that whenever you are asked to plot a graph of two variables, one on the y-axis and one on the x-axis, you have to understand that these are the two variables which are only going to change one with respect to the other. All the other variables of the equation, they are to be considered constant. This is the important thing, because if you have multiple variables changing simultaneously, you cannot practically plot a graph. So the first graph that we are asked to draw over here is a graph of force versus current. So have a look at this equation. If you take force and current to be two variables, so you have to consider B, L, and sin theta, all three of these variables to be considered as constant. So practically you get F equals to a constant into I. So Y equals to mx. So the first graph, force versus current, is going to be a straight line passing to the origin of any gradient, because there is no scale given. So just a straight line passing to the origin is good enough. Logic বুঝে গেছে? আচ্ছা, সেকেন্ড গ্রাফটা আমাদেরকে দিছে হচ্ছে the second graph is given for force versus angle theta up to 90 degrees. So let's have a look over here. So if you are trying to plot F versus theta, the maximum value is 90. So have a look. If you consider F versus theta, the variables which are going to be from this equation, the two variables which are going to be actually proportional, F is going to be proportional to sin theta. F is going to be proportional to sin theta means for a sketch graph, in place of F, you can practically replace this as a sin theta, because the shape of F versus theta would be the same shape as sin theta versus theta, because F and sin theta are directly proportional. So that is the first thing you need to understand, that F and sin theta for this y-axis are replaceable, because these two variables are directly proportional. So whatever the curve shape that we're gonna, you do understand that we're gonna get a curve, because this is a gradation of 30 degrees, 60 degree, and 90 degree. So this will definitely be a curve. So for easier understanding, I'm replacing the F with sin theta. This makes the whole problem much too simpler, because we know exactly how does the sin theta graph with respect to theta looks like. So this is gonna look like what? This is 90 degree, which means you are gonna have
will reach a peak at 90, right?
And become horizontal at 90 as well. ঠিক আছে?
Sir, what if it continued after 90 degrees?
Well, depending upon the phase, you will have to. I mean, the graph of sin theta versus theta graph কিরকম? Sin theta versus theta graph হচ্ছে এরকম. Like this is 90 degree. This is 90 degree. This is 180. This is 270. This is 360 degree. So whatever the amount of angle that shows up on the y-axis, x-axis, you just have to continue the graph with respect to that much shape. If this graph was up to 180 degree, then you'd have to draw this whole thing. If it was up to, let's say, 120 degree, then you might have to draw up to this much, about nearly 1/3 of this graph. That comes from your assumption.
জি স্যার,
বুঝা গেছে?
জি স্যার।
বিউটিফুল। আচ্ছা, এরপরে যে প্রবলেমটা বলছে বি নাম্বার, বি পারছো?
স্যার আমি 13B এর 2 তে এক্সপ্লেনেশনটা বুঝিনি। 13B এর 2 তে, এই 11B পারছি।
আচ্ছা আচ্ছা, 13B2 তে আছি। 13B2 তে বলছে use Faraday's law to explain why the potential difference across the load and the EMFs in the supply are not in phase. আচ্ছা, Faraday's law to explain why these two things are not in phase. Faraday's law practically tells us this thing. Let me squeeze it a little bit. Faraday's law practically tells us this thing, that induced EMF in the secondary coil is gonna be directly proportional to rate of change of flux linkage. This is basically what the entire sum of Faraday's law. When the Lenz's law comes in, that brings a minus sign. So Faraday's law practically gives us this relationship that the induced EMF in the secondary coil is directly proportional to the rate of change of magnetic flux linkage. The primary current is directly proportional to the primary current's magnetic field that it produces, which is also directly proportional to the magnetic flux linkage that it produces. So these three things are directly proportional to each other, whereas the induced EMF is proportional to the differential of it. Now you can see over here, whenever you differentiate any variable, you basically get the gradient of that curve, right? Right?
স্যার আরেকবার একটু বলতে পারেন একটু, আর কি
What I'm
এখানে
saying is
সাউন্ড
that
হচ্ছে।
dy by dx, this one basically represents what? The gradient of y versus x graph, right? So if you
জি, sir.
differentiate d theta by d phi by dt, this basically represents that you are basically gonna plot the phi versus t time, the gradient of this curve. Now phi changes over time in the same shape as primary current, as the same shape as the magnetic flux produced by the primary current. All of these three things would always have the same shape, whereas the EMF would be the gradient of this thing. So if this is a sine curve, as I've shown over here, if you're trying to show the EMF exclusively by Faraday's law, this is supposed to be proportional to the, in terms of magnitude, it's supposed to be proportional to the gradient of this thing. But Faraday's law is not the only law. There is a minus sign for Lenz's law. So we usually plot the negative gradient, which means this is a sine curve. The differential of sine curve is a cos curve. So, and with the minus, we have to plot a minus cos curve. So the EMF versus theta graph is going to be a minus cos curve with respect to time. So that's why there is a phase difference. ফিজিক্যাল রিজনটা কি বুঝছো?
মানে স্যার গ্রেডিয়েন্ট চেঞ্জের সাথে যেহেতু আমরা মানে রিলেট করতেছি এন্ড মাইনাস সাইনটা আছে, সো দুইটা মিলে ফেজটা চেঞ্জ হয়ে যাচ্ছে যখন আমরা ইএমএফ ভার্সেস টাইম গ্রাফ আছি।
এক্স্যাক্টলি, ঠিক আছে। আমি তারপর মার্কসকিমের ল্যাঙ্গুয়েজটা দেখতেছি, মার্কসকিমের ল্যাঙ্গুয়েজটা যাতে তোমাকে বুঝাই দিই। 13b, I'll have a look at it. In the 13b question we have EMF induced is proportional to rate of change of magnetic flux linkage. So they, acha, B2, sorry. Magnetic flux in phase with the, or proportional to the EMF or the current of the primary coil. EMF or current of the primary coil. So the thing that I said, that the primary coil's current produces the B. EMF or PD across the secondary coil is proportional to the rate of change of flux. So these two things cannot be in phase because one is one variable, the other one is
মানে এখানে তো স্যার ফ্যারাডেস ল থেকে বলতেছে, রাইট?
এক্স্যাক্টলি,
মানে E = মাইনাস
এক্স্যাক্টলি,
ডিটি।
বুঝছো এখন?
আর স্যার এরপর বলছে সো ইএমএফ অফ সাপ্লাই নট ইন ফেজ উইথ পটেনশিয়াল ডিফারেন্স, মানে যেহেতু দুইটা মানে আলাদা ইয়ে থেকে ইকুয়েশন থেকে আমরা রিলেট করে আবার গ্রাফ আঁকতেছি, সো
ওই দুইটা ডেফিনেটলি ইন ফেজ হতে পারবে না।
জি স্যার।
আচ্ছা, Examination report আমরা দেখি B2 এর there is a phase difference because the magnetic flux is in phase with the EMF across the primary coil, whereas the potential difference across the load is proportional to the rate of change of flux. The question asked for an explanation that uses Faraday's law, and so explanations that use Lenz's law were not awarded any credit because this question was precisely asking for Faraday's law. Kids, just a second. জি মামুন বলো, বলো বলো, আমি ক্লাস নিচ্ছি, তাড়াতাড়ি বলো। তাহলে আমাকে 10টার দিকে কল দিও। Sorry about that. So explanation that use Lenz's law were not awarded any credit, which means that if there are some students who exclusively use Lenz's law for the minus sign, they didn't get any credit. But if someone mixed up both of these things, they're gonna get credit, they're gonna get marks for the part that is relevant for Faraday's law, because the question specified that use Faraday's law of explanation. So they did not ask for any inclusion of the Lenz's law, so that didn't get any credit. One misconception was that the phase difference was caused by the primary coil having a different number of turns to the secondary coil. This is absolutely untrue. The primary coil having a different number of turns only affects the magnitude of the maximum voltage that we're gonna get. The bigger turn coil will always be associated with bigger voltage. Vp by Vs equals to Np by Ns. That's that. But the phase difference is coming from Faraday's law because of the rate of change of flux. Okay, so that's that. The next question that we've asked is 17C2. Let's have a look. No. This is 17. We have a curve C. Okay. Acha. I'll help you to understand this problem. The idea of this question is that we have a pole of a certain magnet over here, and we have a coil that is over here. This is the axis of the coil and magnet, and this is the distance from this pole. The question is showing us that using this coil, the average magnetic flux density B through the coil varies with the distance x between the face of the magnet and the plane of the coil as shown in figure 4.2. So somehow this coil might as well be a Hall probe coil, but somehow we have used this coil to measure the magnetic flux value, magnetic field density or magnetic flux intensity B value with respect to distance. So what we have got is that as we slowly getting further away, the B is slowly changing, which is obvious because the field lines are getting spread out, and it's so on and so forth. In A, it is asking us what is the magnetic flux density over here. Hence, the magnetic flux linkage at the coil is this much. Magnetic flux linkage is given by phi equals to NBA. So you just do that NBA part. So B is obtained over here, N is given over here, and A is given over here. So the multiplication gives you the whole thing. Then it says that C, have a look at number C. The coil is moved along the axis of the magnet so that the distance x changes from x equals to 5 centimeter to x equals to 15 centimeter in a time of 0.30 second.
স্যার আমরা তো এখানে প্রথমে চেঞ্জ ইন ফ্লাক্স লিংকেজ বের করব BA ওই ফর্মুলাটাতে, রাইট?
এখানে আমরা দাঁড়া বলছি the change in the flux linkage of the coil. Change in the flux linkage of the coil can be calculated very easily. সেটা হচ্ছে আমরা যে কাজটা করব, change in flux বলছো তো, আচ্ছা let me just copy this part and then I'll do this for you all together. এখানে পেজে জায়গা নাই, never mind. আচ্ছা, চেঞ্জ ইন ফ্লাক্স লিঙ্কেজের জন্য আমাদের জিনিসটা লাগবে, আমাদের ফ্লাক্স লিঙ্কেজের বেসিক ফর্মুলাটাকে রিকল দ্য কোর ফর্মুলা ফর ফ্লাক্স লিঙ্কেজ. Flux linkage is given by phi equals to NBA. Whenever we are moving this coil from x equals to 5 centimeter to x equals to 15 centimeter, among these three variables, which variable is actually undergoing change? Is N changing, or only B changing, or only A changing, or any multiple variables changing at the same time? For this change, which is the variable that is undergoing the change?
স্যার এখানে তো x মানে চেঞ্জ হচ্ছে।
So কোন ভ্যারিয়েবলটা? নাম্বার অফ টার্নস, কনস্ট্রাকশন এরিয়া, নাকি
এটা চেঞ্জ হচ্ছে?
A.
Isn't it?
A represents the constructional area of this coil, which is basically the area of this circle. as you are moving from further away, will the coil become
আচ্ছা
bigger
না
or
স্যার
smaller?
সরি বি চেঞ্জ হচ্ছে স্যার সরি
Precisely, B change হচ্ছে। তার মানে হচ্ছে because B is the only thing that is getting changed, we can logically write the change of flux linkage, which is delta phi, should be given by N into delta B into A. This is a logical equation. Either you can do this and you can find out that what is the difference between 5 to 15. So if you have a look at the graph over here, at 5 centimeter the value is 50 millitesla. At 15 the value is I can see how much, 10, and this is 8 millitesla. At 15 it is 8 millitesla. My baby girl has arrived, so sometimes you might hear some sound. Don't be stunned by that. All right, so this value is 8 millitesla. So you just put those two values, find out the difference, and that gives you the magnetic flux linkage difference. So এই পার্টটা ক্যালকুলেট করতে পারতেছো, ঠিক আছে? শুভ্র, এটা বুঝছো?
জি স্যার
এই
হ্যাঁ মানে
ক্যালকুলেশন বুঝছো?
স্যার হ্যাঁ এটা বুঝছি
আচ্ছা, পরেরটা দেখি।
মানে জাস্ট বিএন করলে তো আমরা অ্যানসারটা পেয়ে যাচ্ছি বেসিক্যালি জাস্ট
রাইট,
এখানে আমাদের ইয়েটা চেঞ্জ গ্রাফ থেকে নিতে হবে
হ্যাঁ। আর তারপর বলছে যে হেন্স
পার্টে মনে কিছু একটা প্রবলেম হয়েছিল আমার
আচ্ছা, মানে পার্ট 2 পারছো?
না স্যার 2 তেই মনে কিছু একটা প্রবলেম
হ্যাঁ,
হয়েছিল
2 তে প্রবলেম ছিল। এখানে তুমি পাচ্ছ হচ্ছে চেঞ্জ ইন ম্যানি ফ্লাক্স লিঙ্কেজ অফ দ্য কয়েল। সো দিস ইজ গোনা বি দিস মাচ forever. Hence show that the magnetic flux linkage of the coil is 3.0. I'm so sorry. This is actually a bit repeated question. I'm so sorry about this. এই যে এই নাম্বার 2টা আবার এখানে চলে আসছে, এই যে 2 আসছে আবার বি আসছে, এই যে এই 2 কাটা যাবে, এটা হচ্ছে না সি এর 2। সামহাও এই পার্টটুকু বেশি চলে আসছে, যে এইটুকু কাটা যাবে, এটুকু আমি এখানে কেটে দিই, পরে এটা নিয়ে আবার বুঝছো শুভ্র?
স্যার স্যার সিটা একটু দেখা দেন মানে সি এর 2 তে প্রবলেম ছিল আমার
সিটা দেখাচ্ছে, 1 মিনিট আমি এখানকার এডিটটা করে নিই, নাহলে আমার পরে মনে থাকবে না। এখানে স্ট্রেট লাইন নাই একটাও, অল আউট হাইলাইট স্ট্রেট লাইন, পেন্সিল, select, flatten all. Okay. See, to them the average EMF induced in the coil. Average EMF is very simple. Whenever we'll be doing this calculation, we did not take into account this much in function of 0.30 second. We only did the calculation using phi equals to NBA. And EMF যদি calculate করতে চাই, EMF equals to what? Minus del phi by del t. So এই del phi টাকে তুমি এখান থেকে বসাবা, আর এখানে বসাবা হচ্ছে 0.30 second. That ratio gives you the EMF generated. বুঝতেছো? The minus would be optional.
হ্যাঁ স্যার মানে ওইটুকু করলেই হবে আর কি
এটুকু বললেই হবে, তোমার নিউমেরিক্যাল ভ্যালুর জন্য এটুকুই যথেষ্ট।
স্যার মাইনাস সাইনটা কি রাখতে হবে লাস্ট অ্যানসারে?
এখানে যে কোশ্চেন আমি দেখছি একবার, average EMF in the coil, change in flux, so final minus initial, 15 হচ্ছে final. আচ্ছা, if you ask me, if I was answering this question says that the distance x changes from 5 to 15. So 15 is the final value, 5 was the initial value. So I would definitely do the subtraction of 8 minus 50 because this is the final value, ঠিক আছে? So if I'm gonna do that in my calculation, this change of magnetic flux linkage, this one should be a negative value. So as a result, whenever I'll do the EMF, this should be a positive value. That's how I would do my math, because the change always means change is not difference. Change means final minus initial. Okay?
Yes, sir.
তুমি ফর দ্য সেক অফ সেফটি একটা কাজ করতে পারো, মানে তুমি ক্যালকুলেশনটা করলা, তোমার মাসা মাইনাস আসলো, এখানে তুমি আনসারটা লেখার সময় মাইনাসটাকে ব্র্যাকেটে দিয়ে দিলা, আর পরে তুমি মাইনাস ভ্যালুটা ইউজ করলে এখানে ইমেজটা তোমার পজিটিভ আসলে তুমি পজিটিভ আনসার দিয়ে দিলা। দিস অলওয়েজ অ্যাকচুয়ালি লিভস ইউ উইথ সাম সেফটি।
মানে স্যার আচ্ছা মানে ইএমএফটা নরমালি পজিটিভই হয় রাইট?
না, ইট ডিপেন্ডস আপন দ্য ক্যালকুলেশন। ওরা যদি এই কোশ্চেনটাকে ধরো 15 থেকে 5 লিখতো তাহলে এটা অবশ্যই পজিটিভ হইতো, সেক্ষেত্রে ইএমএফটা অবশ্যই নেগেটিভ আসতো।
হ্যাঁ ঠিক আছে।
ঠিক আছে,
স্যার ডিটা কিভাবে অ্যানসার করব?
Because was taken on the variation if any the speed of the coil, so the induced EMF remains constant during the movement in C. Okay, this is an interesting question. The question is saying that how should we change if do we I mean the speed of the coil, should there be any variation in the speed of the coil of movement from 5 centimeter to 15 centimeter, so that the EMF generated over this duration remains same. Now try to understand over here. You can see that there is a gradual decrease of gradient, right? Which means
should accelerate.
Yes, sir.
exactly. So which means that over here a small distance movement will give you a large EMF, but over here a large distance move is going to give you a small EMF. Which means if you want to get a uniform EMF, you need to move slowly for around this part, and you need to move pretty fast over here, so that the rate of change of flux pretty much remains the same. Which means as you are going to move the coil from 5 centimeter to 50 centimeter point, you have to speed up the motion, or you can write the coil should accelerate. বুঝা গেছে?
মানে স্যার এটা আমরা আসলে করতেছি কারণ মানে ডিপেন্ডস অন দ্য মানে চেঞ্জ ইন ফ্লাক্স লিঙ্কেজ রাইট?
Precisely.
আচ্ছা মানে যেখানে ফাস্ট হচ্ছে সেখানে ফাস্টলি
না,
মানে যেখানে ফাস্ট হচ্ছে সেখানে স্লোলি আমরা মুভ করাইতেছি কয়েলটা।
এক্স্যাক্টলি এক্স্যাক্টলি,
আচ্ছা
যাতে করে থ্রু আউট দ্য মোশন আমরা ইউনিফর্ম একটা ইএমএফ জেনারেট করতে পারি। ওকে, আচ্ছা এইগুলি গেল। তারপর দেন আই হ্যাভ সাম প্রবলেম ফ্রম মুগ্ধ, and then I have some problem from Rafid. Both of you have sent me direct messages. Why do you send me direct messages? Okay, I'm pasting Mugdho's and Rafid's message once again into the common chat so that every one of us can actually see this. Madam, তুমি কেন আমার রাইট প্যাডকে কিক মারতেছো? Please not do that. I cannot copy. Can I copy this? আমি এগুলো কপি করতে পারতেছি না। হোয়াট ইজ দিস? এই চ্যাট উইন্ডোর মেসেজ কপি করা যায় না?
স্যার জুমের মন ফালতু, কন্ট্রোল সিও ওয়ার্ক করে না।
This is really bad. All right, I'll change my preferences. শোনো, আমি বললাম তোমরা প্লিজ কেউ আমাকে প্রবলেম লিস্ট পার্সোনাল চ্যাটে পাঠাও না, তাহলে বাকি সবার ফলো আপ করতে খুব ঝামেলা হয়। বাট ফর দ্য টাইমিং I'll do my magic. All right. I'm gonna put this where? I'm gonna put this right here. Okay, তোমরা এখান থেকে দেখো। তোমরা তো এই লিস্টটা তোমরা দেখতেছো না সবাই? This whole writing, can you see this whole writing? Everyone, can you see it?
Yes, sir.
Okay, I had to ask multiple times because right over here I have the participant list, and underneath that I have kept the snipping tool, so I had to make sure that you guys are seeing it properly. Okay, I'm gonna keep it right over there so that you can read this if you need it, and I'm gonna start working from here. So the problem that Mugdha has given us is Mejun 1441, question number 7A and B2. Let's pick that up. Mejun 7, Mejun 14. Mugdha আছো এখানে?
Yes, sir.
Okay. Uh, 41 and 41. we are gonna try question number 7. We're gonna try question number 7. 7. There you are. The question says a solenoid is connected in series with a battery and a switch. A Hall probe is placed close to one end of the solenoid, as illustrated in figure 7.1. Afrida. Okay. The current solenoid is switched on. The Hall probe is adjusted in position to give the maximum reading. Okay. The current is then switched off. Acha. This is a nice question. Good pick. Well done. The current in the solenoid is now switched on again. Several seconds later, it is switched off. The Hall probe is not moved. On the exercise figure 7.2, sketch a graph to show the variation with time t of the Hall voltage VH. Okay. The moment we're going to close the switch, okay, how does the Hall probe, what type of voltage does the Hall probe detect? Try to remember the equation for Hall voltage. Does anyone remember the equation for Hall voltage?
VI by NTQ.
Just a second.
BI by NTQ. Not VI.
Sorry, I was taking care of my baby girl. I'm really sorry for this interruption, but this has become part of my actual কি বলে হোমস্কুলিং। যাই হোক, এই জিনিসটা আমরা একটু খেয়াল করি। হল প্রবের যে কোর ইকুয়েশন, এই ইকুয়েশনটা কি ফার্স্ট অফ অল আমরা আমাদের কোশ্চেন পেপারে পাবো কিনা? আর উই গোনা হ্যাভ দ্যাট ইকুয়েশন? লেটস হ্যাভ এ লুক। ডু ইউ হ্যাভ দ্য ইকুয়েশন অফ Hall voltage over here? Do we? No.
Yes, sir.
We don't.
We do.
Wait. হ্যাঁ,
আগে তো BI by NTQ তো ছিল স্যার।
কই এই আর তো নাই, এখানে তো কোথাও দেখতেছি না। I know that equation. I can write this. I'm just looking that are we going to have this equation in this list? Apparently, we are not going to have this equation within this, which means you have to know / remember / memorize this equation. So I'm going to write this equation and start working through for this graph. So we are trying to do which graph? What is this graph? This one. So let's try this. I haven't seen the mark scheme, so I might actually be wrong, but I'm going to try on my own idea first. But if I'm wrong, then I'm going to try to find out an explanation for the actual mark scheme. But let me try this. So VH is given by BI divided by NTQ. Am I correct? Eta na?
Yes, sir.
Acha. So এখানে একটা জিনিস দেখো, n is the number of charge carrier per volume of the right thing. T is the thickness of the Hall probe material. Q is electrons charge. I is the current flow through the Hall probe, which is typically kept a constant. So Hall probe versus B, this is typically proportional. So if you have a high magnetic flux, you're going to have a high voltage. If you have a low magnetic flux, you're going to have a low voltage. So VH will be proportional to B. VH is not proportional to delta B. So the idea is whenever I need to make a screenshot of this thing. But if I make a screenshot of this thing, I'm going to lose this thing. So let me just use actual print screen. Where is print screen? And then let me place it over here. And then select. I lost this part. Control Z. No Z, Hana. Control Z. Okay. Okay. আচ্ছা হয়েছে এখন। আচ্ছা। So whenever the switch will be just closed, current is going to start flow through the solenoid, and the current will increase for a small duration. And just after a little while, the current will reach its peak value. For the duration when the current will be increasing, the magnetic flux produced by this solenoid will also increase. And after the current has become constant, then the coil will simply keep on producing a constant value of current or constant value of magnetic flux. So if you ask me, the way this graph should look, I'm trying to draw with red. From here is going to be 0, 0, 0, 0, 0, no Hall voltage. This is the point from where the Hall voltage will start to increase. So disregard this zigzag. My hand is shaking, so I'm having. So it is going to rise from here to a certain value. They haven't given us any scale, so you're going to show this rise, pretty sharp rise over here. And maybe then you make it constant. This will keep on constant till the moment the switch is closed. Let's say this is the point when the switch is closed. From this point, the current value will start to drop. So there will be a gradual decrease of this current. So there will be a gradual decrease of this current starting from this point, and it should take the similar amount of, let's say over here I took 3 divisions to show the maximum increase of current. So I'm going to try to show the same 3 divisions of for decrease to keep it symmetric on both sides, because we're working with the same coil, and this should go down like that.
বুঝলাম না এরকম কেন হলো?
Because the current starts to increase over here. I'm assuming within this much time the current reaches its peak, because definitely the current will reach its peak with some time. Because in microsecond level or even picosecond level or nanosecond level even, the current should start from 0 and reach to the maximum value within a certain measurable amount of time, because the electrons have to accelerate from 0 speed to the optimum drift equation speed, I equals to NAVQ or V. So it's going to take some time. So I'm trying to signify that time amount over here. That's why I'm not showing a vertical rise or a vertical drop. I'm showing that time because there will be some time involved. And here the current starts to increase. I'm assuming here the current becomes maximum. Thank you. And that maximum current is maintained over this duration, and here the switch is turned off, and let's assume that this is the amount of time it takes to drop. So this is the graph that I am guessing it should be.
স্যার ডিসি কারেন্ট দেখেই তো একটা সিঙ্গেল ভ্যালু অফ কারেন্ট আসছে তাই না?
That's why we have a flat line.
হ্যাঁ, যদি এসি হইতো স্যার বাই চান্স, নাকি এসি দিয়ে হবে না?
এসি হলে আমরা এই এসি কারেন্ট ভ্যালুর প্রপোর্শনাল একটা ম্যাগনেটিক ফ্লাক্স চেঞ্জ দেখতাম। এসি হলে আমাদের কি হয়, the current in the coil is directly proportional to the B produced, and that B would be directly proportional to the Hall voltage produced. So whatever the incoming phase of the input current, the Hall voltage should have the exact same phase. Magnitude should be different because this would be plotted in milliampere or microampere or ampere scale. This would be plotted in volt scale, but they would have the same shape, same phase.
স্যার তাহলে কি সাইনোসয়েডাল হবে?
Definitely.
আচ্ছা,
yeah, Mugdho, এইটুকু পর্যন্ত বুঝছো?
Sir, I did the same thing, but sir, আপনি যে rise-টা দেখিয়েছেন, you took some time. I assume that it would be instantaneous, as in I showed a vertical line.
But that's the precise thing that you shouldn't do. Showing a vertical line would mean that irrespective of the scale of this time scale, irrespective of the scale, this, whether it is in hour or it is in picosecond, there would be an instantaneous rise of voltage. The voltage will not rise instantaneously, because for the current to rise from 0 ampere to the optimum peak ampere value, it will always take some time. Now, let me clarify this. If we plot this graph, let's say within a minute scale, if the minute of this time is minute, in the CRO scale, this will appear to be a vertical line. If you start to reduce the unit of this time, let's say from minute you get second, then let's say you get millisecond, or then the smaller time you're gonna get, the wider this is gonna become. So this is a more magnified and more precise representation of what is gonna actually happen.
Yes, sir, I got it, sir.
Drawing the vertical line is not wrong, but it's not entirely correct, because there can be a variation of that vertical line given enough precise scale.
Sir, it depends on the time base, that is.
Precisely. So মার্কস্কিমও কি এরকম দেওয়া ছিল? মার্কস্কিম দেখি,
Sir, I don't remember.
আচ্ছা মার্কস্কিম দেখি, সমস্যা নাই। আচ্ছা, তোমার প্রবলেম ছিল হচ্ছে এইটা A and then B2 তে আমাদের একটা গ্রাফ আছে. Let me try this one once again, then I'll go for that one, or I can actually I'm actually curious to find out this error. আচ্ছা, এটা কত নাম্বার ছিল? 7. I'm going to the mark scheme. Graph VH increases from 0 when current is switched on. VH then non-zero constant returns to 0 when current is switched off. Okay. Okay, only this. So, okay, hold up. Your graph should also score full marks according to this graph, these 3 points, which increases from 0 when current switched on. So if you show a vertical rise when current switched on to a non-zero constant, a positive or negative value, and keep it constant till the point of the zero, and then at the switching off point you draw a vertical drop and show it 0 current for the remaining of the time, according to this mark scheme you should get full marks. I don't see any problem here, but let's have a look at the examiner's report to get a bit more insight. Maybe ER 41 question number 7. A, the graph needed to show the voltage increasing sharply from 0 when the current is switched on, followed by a section with the voltage remaining constant, and then the voltage finally decreasing back to 0 when the current is switched off. A common error was to show the voltage decreasing before the current is switched off. A significant portion of candidates appear simply to guess a graph shape such as a sine curve. It is important that candidates are given opportunities to perform practical work using Hall probes in order to enhance their understanding of the underlying physics that is assessed in this kind of question. Okay, makes sense. বুঝছো তো? এখানে তো মানে কমপ্লিটলি কিছু বলে নাই।
Yes, sir.
Okay. আচ্ছা, এটা গেল. Let's go for the next problem that you proposed. This graph, the Hall probe is now replaced by a small coil. This is where the problem is getting interesting. The Hall probe is now replaced by a small coil. The plane of the coil is parallel to the end of the solenoid. The plane of the coil is parallel to the end of the solenoid, which means that now this coil that we are placing, let me just try to draw a coil, maybe with blue. This coil, let's say, looks like this. But the plane of this coil is perfectly flush with this circular plane. Okay, which means essentially the magnetic field lines are essentially going through it like that. So we have a pretty huge cutting of the magnetic field lines if there is a change. Then the question says, state Faraday's law of field remaining in action. এটা আমরা normally লিখলাম. Two tables on the exercise figure 7.3, sketch a graph to show the variation with time t of the EMF E induced in the coil when the current in the solenoid is switched on and then switched off. So how would the induced EMF should be working? Beautiful question. Let's go for it. So I'm going to once again use print screen and then take it up onto a new space. Let's take it over here. So this is the graph that we're trying to achieve. So when the current will be switched on for a duration, there would be a EMF. That EMF would be a spike EMF. let me elaborate this, why this should be a spike EMF. Try and understand. If there is a coil and we are measuring the EMF induced within this coil with a CRO or a voltmeter, I'm just drawing a voltmeter for simplicity. This voltmeter should only give us a reading. Hear me out very, very carefully. This voltmeter will only give us a reading whenever there is a change of magnetic flux linkage over here. So we need to have delta phi to exist. A constant phi would not give us any EMF. We need to have change of phi. Change of phi comes from change of current. Change of current happens for a very small duration, like let's say over here I have shown three divisions. After this, the current becomes constant. So when the current becomes constant, this voltmeter will give zero again. So here's the deal. When the switch is closed, the magnetic flux linkage will increase. So there will be an increase of cutting. So the voltmeter will give you a momentary reading. So it will spike up, let's say in positive direction, and immediately come to zero for the same amount of duration till which the current becomes constant. The moment the current becomes constant, del phi is gone. There is no change of flux linkage. So once again, the induced EMF will become zero. This is the first part I need you to appreciate. Let me finish, then I'll take questions. When it will be switched off, the current will be decreasing. That decreasing current will now slowly start to reduce the magnetic flux linkage of this coil. Once again, you're going to have del phi, but now the del phi will be in negative direction. So in the earlier case, let's say from 0 you had a positive increase. Now from a positive value you are having to 0, so that's a negative change. That's why in the switching off condition, that induced EMF should happen in the negative spike. So you are going to have a negative spike over here. Logically, what I'm trying to show you, that if I have shown over here out of no physical reason, this is just a random thing, that I used over here 3 divisions to represent the increase, and I used same 3 divisions to show the decrease, 1, 2, and 3. So this entire spike should also have 3 divisions. This entire spike should also have only 3 divisions. How much peak and how much bottom do you expect? That's up to you. But the magnitude of this one and the magnitude of this much, both of these magnitudes should be same, because we are working with the same coil. So your current might be increasing from 0 to, let's say, 1 ampere. Then it's going to drop from 1 ampere to 0 ampere. So the del phi would have the same magnitude, but in opposite direction. So how am I going to draw this graph? If you ask me, I'm going to draw this graph like that. Let me show you. I use 3 division over here, so I'm keeping a synchronized drawing over here. It's not important that you have to maintain this you have to maintain this synchronization between the two graphs, but I want you to understand why this is important or why this is applicable. As long as you understand it better, you will be less likely to make mistakes. So I'm going to start the spike over here. I'm going to finish the spike over here. Just out of curiosity, let's say I'm going to give a 10 division spike. So let's say I'm going to show the peak over here. So what I'm going to do, I'm going to show the current 0, induced EMF 0. Then let's say we draw a straight line. You can choose to draw a curve, but drawing a curve can be actually pretty difficult. So drawing a straight line is actually not a bad thing, but drawing a straight line can have its own problems. The problem is that you are actually showing over here a very large cornering. Actually, these things are going to be smooth curve. You're going to have sharp peak over here. You're definitely going to have a corner over here, but the bottoms can be rounded. That they usually become rounded. I'm not getting into reasons that why they are supposed to be rounded. If you want to use a ruler, you go ahead and use a ruler. No big deal. You will not be losing mark for it. So you show a spike over here, and then you maintain this 0 current up to the point the switch is opened, up to this point, and then on the lower side you're going to show that same thing for a duration of 3 divisions. So spike at 10 division bottom and 0 comes at 10 division top.
So sir,
and শেষ করি
মানে VH এর সঙ্গে
শেষ করি তারপর কোশ্চেন নিচ্ছি। সো এই জিনিসটা হচ্ছে সিচুয়েশন। এখন আমাদের এই পয়েন্টগুলোতে হরাইজন্টাল হওয়ার কারণ হচ্ছে, ইউ হ্যাভ টু আন্ডারস্ট্যান্ড, ফর দিস পার্ট কারেন্ট ওয়াজ 0 constant, for this part current was something but constant, for this part also current is 0, so constant. This is the part where the current was increasing, this is the part where current was decreasing. That's why we have induced EMFs in these two places, because these are the only two durations where you're going to have del phi. Okay, I'll take questions. Go ahead. Shubro bolo, tapor mugdho theke question nichi bolo.
Sir, এখানে আসলে ডিফারেন্ট কেন হচ্ছে যে ইএমএফ ইটা ইনডিউসড ইন দ্য কয়েল আর ওখানকার ভিএইচটা লাইক
দেখো বুঝায় কিনা। I wrote two equations. See if it makes sense. নাহলে আমি বুঝাবো আবার, don't worry.
স্যার মানে একটা হচ্ছে কারেন্টের সঙ্গে প্রপোর্শনাল আর একটা হচ্ছে মানে চেঞ্জ ইন ফ্লাক্স লিঙ্কেজের সাথে
Precisely.
রেট অফ চেঞ্জ অফ ফ্লাক্স লিঙ্কেজ।
মুগ্ধ বুঝা গেছে ক্লিয়ারলি?
Sir, হ্যাঁ স্যার, like আমি একটা ছবি পাঠিয়েছি স্যার গ্রুপে। Sir, could you see if I would get the marks if I drew it this way?
This is not entirely wrong. I wouldn't say it's wrong. If I just have a look at the divisions over here, first of all, I hate the thickness of your pencil. Whether your graph is correct or not, I hate the thickness of your pencil. That goes without saying. Then if I start to observe, here you have used how many divisions? 1, 2, 3, 4, 5, 6, 7, about 8 divisions. Here you have used 1, 2, 3, 4, 5, 6, 7 divisions. So there is a 1 division discrepancy over here. On the vertical side, you have used 10 divisions. Over here, you have used 10 divisions as well. So the vertical spacings are good. I'm going to have a look at the mark scheme to find out how much mark are we going to get, or are we going to lose any mark or not. This graph looks good. It shows that you understand the concept. But are we going to get full marks or not? I have to look it up from the mark scheme. 7b2 pulse as current is being switched on, 0 EMF when current is when current in coil, pulse in opposite direction when switching off. You're gonna get the mark, full mark for this drawing.
Okay sir, thank you sir.
Beautiful. আর কারো কোনো কোশ্চেন এই গ্রাফটা পুরোপুরি বুঝা গেছে? হ্যাঁ বলো।
স্যার ভিএইচ মানে আমরা আসলে কোথায় কোথায় মানে হল ভোল্টেজটা আসলে মানে লাগে আমাদের, why do we measure it in the first place?
We measured the hall voltage to have a measurement of B. Hall voltage equation is given by VH equals to BI divided by NTQ.
আচ্ছা, to find out the B.
Exactly.
So basically,
so hall voltage is, hall probe is basically the physical device that we have most commonly available that we can use to measure the magnetic flux intensity at a given location. We measure the voltage by
sir,
voltmeter,
number of
by
charge
ammeter.
carriers.
This is a constant that it depends upon the hall probe material that you choose. So this is a constant that is put into the algorithm of the hall probe. T is the thickness, that's the measurable, and Q is the electron charge. So basically, except for this one, we can actually physically measure, or we know all of these other variables. So B can be easily calculated out of this equation. That's the beauty of it. All right. The other question that Mugdha gave me was ON41. Nah, sorry, ON18 variant 41. Okay, let's pick it up. Mugdha, this was a very nice question. Good one. Thank you. W18 41. Let's pull up everything because we're gonna need them anyway. Do we have the examiner's report or the combined examiner's report? Sure, why not? All right. এই যে দেখো এখানে আবার হল ভোল্টেজ ইকুয়েশন দেওয়া আছে. What is this? Isn't this just, I mean, the year they gave a question about the hall voltage, they ate up the formula. This is just
Evil, cruel.
I mean, cruel doesn't even begin to explain this.
Tyrannical.
This is
Orwellian, dystopian, nightmarish.
So what are you talking about?
This is crap. Like, I feel infuriated. This is really bad. Anyway, CIE does his job. Okay, the question that you've given me is for 1841, question number 9b2. Question number 9 says Faraday's law of electromagnetic induction. A solenoid S is wound on a soft iron core as shown in figure 9.1. Okay, what do we have here? We have a coil C with a voltmeter. We have a battery that is produced over here. So pretty much the same stuff. We have a Hall probe that will be affected by DC coil switching on and off coil, and we have also a coil that will be affected by this one. So EMF would be induced over here, and Hall voltage would be induced over here. Okay, Hall voltage would be maintained for a long duration for as long as the current exists. Pretty much the same question, I think. But you asked a question about this part. Okay. Eta parso.
Yes, sir. Samta perechi, sir.
Acha, grateful. Complete figure 9.2 for the voltmeter readings for the times before, during, and after the duration of the current is reversed. আচ্ছা, এটা বুঝার জন্য আমার ফুল কোশ্চেন একসাথে দেখা লাগবে। Let me try that. Okay. পুলন, তোমরা কোশ্চেন পড়তে পারতেছো কি আদৌ? ফুল করলে তো অনেক জুম আউট হয়ে যায়। দাঁড়া, আমি কোশ্চেন একটু পড়ে নেই, তারপর তোমাদেরকে হেল্প করতেছি। জাস্ট গিভ মি সাম টাইম। Consi having 120 turns of wire is 1 to 100 because the cross section of the coil C is 1.5 centimeters square. Hall probe is close to the other end of the core. When there is a constant current in the solenoid, as the flux density in the core is 0.19 Tesla, the reading on the voltmeter connected to the Hall probe is 0.20 volt. Okay, they didn't mention the current, but they have said that for a certain constant current, we have these values. The current solenoid is now reversed within a time of 0.1 second at a constant rate. Achha, reverse means within 0.065 second they made it 0, and then within the next 0.065 second they made it in the opposite direction maximum. Okay. So calculate the reading on the voltmeter current in the coil during the time when the current is changing. Then it says complete figure 9.2 for the voltmeter readings for the times before, during, and after the direction of the current is reversed. Reading on voltmeter connected to the coil. Before the current changes, আচ্ছা, এটা করার জন্য আমার অ্যাকচুয়ালি এটা লাগবে। Can I get a new instance of snipping tool? I cannot. Okay. Then how about I copy this, get a new instance of paint, make it small, and paste it here, make it small, and keep it here so that you guys can see it, so that I can use my snipping tool for my purpose. Yay. Acha, although you kids are gonna pass away from pass out means organ hawa. Pass away means mara jawa. What does it mean? What is the word for graduation? Passing out, or
I think it's passing out of school, I think.
Passing out মানে অজ্ঞান হয়ে যাওয়া না?
মানে passing out, just passing out বললে it's মানে অজ্ঞান হয়ে যাওয়া, but like if it's passing out of school or high school,
আচ্ছা,
that's graduation.
আচ্ছা that এই যে কি যেন বলে এটা রে, transitive verb, intransitive verb, ভুলে গেছি। That other additional part makes that word. Okay, fine. So although you are gonna passing out, Sohel actually I'm on a completely different note than physics. Sohel actually proposed me one thing, that is in our new coaching galaxy that we have said a lot. He proposed me that I should buy a really wide screen TV, like 85 inches or so, and use the kind of setup that I'm using right now, voice channel and the write pad, to write everything in the paper and make explanation over there, and move as least as I can, so that exertion is less and I can take problems more. I can do problem solving more intuitively without actually walking or being too much tired. what do you kids think? Would that be a good idea to move out from traditional whiteboards and actually go for that kind of method?
Sure, there are advantages and disadvantages. If you use that screen, you may be able to show more simulations that you wouldn't usually show in class, right?
Yeah.
Number one. Number two is, I remember there was this one class, রাতে হচ্ছিল লাইক রাত তখন 10:30 মতো বাজে, প্রবলেম সলভিং এরই ছিল, আমরা 5-6 জন ছিলাম, and like you got tired of walking around, so you just sat down and you were taking problems, and then you fell asleep on the stage.
In class.
Yeah.
Okay.
So এখন আমি জানি না যে আপনার বসে থাকলে if it's going to be more beneficial for you.
No, this is actually going to be pretty beneficial for me, because the one thing that I actually have come across to understand that whenever I take typically a 2-hour class of, let's say, 40 kids, I actually cannot give an equal quality lecture for the next 2-hour class whenever I have consecutive 2-hour classes in a 4-hour slot. So that I know for a fact, which has been happening for, let's say, for the last 1.5 years or so. I got old, bottom line.
Yeah. Well, then I think Sohail sir's suggestion is good.
Anyone
Well
else? Do anyone else have any input about this? What do you kids think?
Sir, what did you suggest?
That I totally discard my whiteboard. I buy a pretty large widescreen TV, like 80 or 85 inches or so, and teach the kids in the same way that I'm teaching you right now, using the right pad and computer simulation environment, and do the lecture with the voice channel and microphones and mics in all the pieces. So I have to walk less. I can pretty much be in the same location and do this thing, and all the notes will be provided in printed form, so there is no question for writing notes like I'm gonna fill up the whole board with writing and students are gonna copy it. No such thing. Only explanations done by multimedia staffs. So the entire whiteboard is gone.
Sir, it may be unpopular opinion. My hot take is you keep the whiteboard, because you can just use a projector if you want to do something.
Using a projector actually sounds like a very good idea, but one of the things that I really don't like about the projector is that the projector's lumen value is something that I have to be really care about, whereas the TV's brightness can be controlled. I think projector can also work. I mean, projector can also have exactly similar output, right? If I have an HDMI cable, a pretty long HDMI cable, which can be bought, they are available in this country. So other than buying a large, I mean, what Abhias you are saying, that other than buying a large TV, having a powerful enough or workable, good enough projector would be a better idea. Is that what you're saying?
Yes, sir. Because a TV would kind of become hard to manage and maintain. It could get easily damaged. It works in theory, but in practice, I don't think it would really
those
work.
large panel TVs. I mean, let's say someone out of no practical reason just shoots a pointy object at the screen and it cracks the whole screen and just, yeah, that's a physical damage that I can.
Yes, some raving lunatics, sir.
But projectors are more sturdy than a basic screen. Yeah, that totally makes sense. I hadn't thought of it. So it would be, I mean, if I go for the TV screen thing, I might have to install let's say a polystyrene sheet or for acrylic layer, like bulletproof glasses in front of that. That might be a good idea, but that's going to give glare, so that's also not pragmatic. So projector is pretty much the last option. So having the whiteboard in front of the whiteboard, having the roles to run the projector, and then use doing everything in the computer environment like I'm doing right now. Maybe get used to better softwares like whiteboard or other things other than using MS Paint. I think I'm pretty good with MS Paint, but I believe that other softwares can actually give me better pace, which I need to be accustomed with. Okay, I got my useful feedback. Anyone else would like to add anything new other than what we've discussed right now? I'm asking you kids because I believe that you kids can give me good insights. Digital whiteboards can also, you just wrote that digital whiteboards are pretty good stuff, but digital whiteboards have some really significant limitations. I mean, the flexibility that you get on a whiteboard is not as much in a digital whiteboard. Digital whiteboards are nice. For example, I've seen actually the use in actual print person is of some digital whiteboard in Uttara Scholastica when I did training, my only training with CIE when I used to be in ESS. Lucky enough to get the chance. I am definitely indebted to the ESS authorities to send me for the training. But I saw that it's good, but it did not struck me as a miraculous thing. Okay, anyway, let's get back to the problem. I'm sorry for the distraction. It just popped in my mind, and I've been I was thinking to get you kids' opinion because I value it anyway. So this is the question that we're going to try to solve. So, and the problem that we have, I need to get the problem as well. So this is over here. Mugdha,
Yes, sir.
sorry for the interruption.
No problem, sir.
Okay. So there we are, although a bit mismanaged, but bear with me. So the question is this. Did I miss anything? Yes, I missed out this line. The current in the solenoid is now reversed within a time of 0.13 second. এটা কেন মিস করলাম? আমি একটা stupid. All right. এখন ঠিক আছে। So complete figure 9.2 for the voltmeter readings in the for the times before, during, and after the duration of the current is reversed. So before the current changes, during on the voltmeter current to cause before the current changes. So when the okay, kids, okay, I'll help you. The first thing I want all of you to understand, this question tells us that at the beginning, there was a current, constant current in the solenoid S, and that gave us a flux density of this much at the core, and the Hall probe was giving us this much reading. So the situation is starting with a current existing within the coil. That is our starting situation, not the other way around. And then the reading on voltmeter current to the Hall probe, these things are going to undergo some changes. Okay, so let's have a look. Before the current changes altogether, this coil should read 0, because this coil should only give you some reading whenever there is a change in current over here. So I'm going to write 0. They have already given the unit over here, so I'm not going to bother to write the unit over here. During current change, when current is 0, we're going to have a value. We're going to have a value of how much? Let me find this out. We're going to have a value of this B1. What is the value of B1? মুক্ত B1 এর value কত ছিল?
Sir, 0.053.
So you're going to get that value over here, because they have said precisely that we're going to make that change at a constant rate. So you're basically going to get an uniform voltage for that duration. So during the current change, when the current is 0, you have to understand one thing. During the current change, when the current is 0, it means you are continuously changing. Let's say this is the graph of current versus time, I versus t. So you have a constant current, then you reverse the current uniformly, then it becomes constant again. So even when this is 0, the rate of change of current is not 0, because it is still a part of a inclined straight line. So it will still have some value. After the current changes,
স্যার কি দিয়ে
0 once
ক্যালকুলেট
again.
করলেন?
Sorry,
মানে ডিউরিং কারেন্ট চেঞ্জ এটা কিভাবে ক্যালকুলেট করলেন?
আমি ক্যালকুলেট করি না, এটা B1 ছিল, আমরা তো B2 তে ফিল আপ করছি, B1 এর ক্যালকুলেশন ছিল, যেটা এই যে এই
ও,
ভ্যালুগুলো phi equals to NBA থেকে বের করতে হয়েছে. Then it says that reading on the voltmeter current to the Hall probe before the current is 0.20 volt. এটা আমার ওদের অলরেডি কোশ্চেনে বলে দিছে. during current change when the current is 0. This would be 0 because B proportional to I. So sorry, VH proportional to I. So if the current is 0, the VH will also be 0. After the current changes, this will be minus 0.20. These are my answers, logically thinking. I might be wrong. I'll check with the AMR scheme. But do you understand why these values are like this? Logically বুঝা যাচ্ছে কিনা?
Sir, when I did it initially, যেখানে 0.053 লিখেছেন, আমি ওখানে half ভ্যালুটা লিখেছিলাম because I thought half the time, so half the voltage change.
No. Here's the thing. The question says that S is now reversed within a time of 0.013 second at a constant rate, which means, let's say if this was 10 ampere, although pretty unlikely, but let's say this is 10 ampere, this is going to be minus 10 ampere. And the entire duration of this change from here through here is 0.13 second, this whole duration. But for this entire duration, you're going to get a constant voltage output. Same voltage output over here, everywhere you're going to get the same voltage output because you're going to have a constant drop of current. Do you get my point?
Yes, sir. The rate is constant. That's why we're going to get a constant value.
Exactly. আমরা এই ভ্যালুগুলো একটু চেক করি মার্ক স্কিম থেকে and let's see if you're wrong. Yes, Avias, go ahead. Sorry. Avias বলো, কিছু বলতেছিলা?
Here it's just basically saying d phi by dt is constant.
Yeah.
Okay.
0 reading on the voltmeter 0.0530. Good. Reading on the voltmeter current to whole probe here 0 in the middle column, final column current sign negative, final column current magnitude 0.020. Okay, so to be honest, here in this, here you are going to get 2 marks. This the writing has 2 marks, having the same value, 1 mark, minus 10 marks. So there are 4 marks over here. This is weird. What is the mark scheme distribution? So the lowest column has 3 marks in it and the top column has only 1 mark in it. Okay, so this, I mean, all 3 of them correct gives you 1 mark. You mess up any of these, you don't get this mark. And this itself has 2 mark and this exclusively have 1 mark. Good mark scheme. 5 blanks and 4 marks. But it works. Does it make sense? বুঝা গেছে কিনা এটা বলো?
Sir, is it
Yes,
1?
sir.
হ্যাঁ, এই মার্কটা হচ্ছে 1. এইখানে 0 ভ্যালু 0 মার্ক হচ্ছে 1. এখানে 0.20 ভ্যালু ম্যাগনিটিউডের জন্য 1, মাইনাসের জন্য আরেক 1, এই হচ্ছে 2, আর এই পুরো তিনটা ভ্যালু সাইমালটেনিয়াসলি কারেক্ট হলে হচ্ছে বাকি 1, এই হচ্ছে টোটাল 4 মার্কস. All right, we have completed the list for from Mugdho. Then we're gonna Anna arekta problem আছে. Measure 1641 10B. Let's look it up. Measure 1641 10. There you are. And a coil of insulator wire is wound up on a copper core as illustrated in figure 10.1. Copper core. Why? Okay, anyway. And then alternating current is passed. Sorry, through the coil. The heating effect of the current in the coil is negligible and why the temperature of the core rises.
Sir, I had problems with B.
2 hollow tubes of
Not-
equal length. 2 hollow tubes of equal length hang vertically as shown. Yeah. One tube is manufactured to small. You could not answer this question, right? I mean, this didn't make sense at all, right?
Sir, I did write it, but what I assumed was that EMF is going to be induced in the plastic tube, but apparently it's
what?
not going to be induced.
EMF
Yes,
is,
sir, that's what I assumed wrongly.
you assume EMF is going to be produced in the plastic tube?
Yes, sir.
Why? It doesn't have any moving electrons.
Well, I thought, but sir, I thought magnetic flux cuts it, so I thought there were going to be some free electrons.
No, no, no. Change of magnetic flux does not give objects better conductivity. No, better conductivity is relevant to their materials construction, atomic level construction, and also the temperature. These are the only two variables that control conductivity or resistivity. The other term, opposite side of that, other opposite term of conductivity. Magnetic flux change does not cause particles to have conductivity. Strong magnetic fields can control their spin, which we have learned in the MRI, but not conductivity. বুঝছো কি বলছি? আচ্ছা,
Yes, sir.
so এখানে যে জিনিসটা হয় যে whenever this magnet B is falling through the aluminum tube, as circular sections of the aluminum tube experiences change of magnetic flux linkage because a pole is getting closer. I mean, try to think about this whole aluminum tube as small circular sections, like a solenoid, but in a small circular section. So they are gonna experience a change of magnetic flux linkage. So they will try to produce a current in such a way by Lenz's law so that this magnet cannot actually make this journey. But it will definitely make this journey because of the weight. But it has to continuously overcome that repulsive force. That's why it is gonna fall much slower. There's a very amazing YouTube video for this. I can actually show you that. Did you see that video ever?
Sir, the one by Michael Stevens. Or-
You just referred a name. I'm not sure, but I'll definitely look up his name. Michael Stevens. This one.
Yeah, like his channel is called DONG. Dong.
Michael Stevens is Vsauce, right?
Yes, Vsauce, pretty much. He made a video about Lenz's law.
Where is that? Okay, let me Michael Stevens Lenz's law. কি করলাম? No, I don't think.
He also demonstrates.
He demonstrates the pipe thingy.
He demonstrates the effect. Yeah, he does.
Okay, I'm gonna pause the recording. Resume the recording. So apparently Arnav is not with us. Acha, if Arnav is not here, I cannot actually see the point to discuss this problem because I would need his feedback whether he understood it or not. Does anyone else among you have any problem that you would like to post here? If you don't, then I'm gonna get back to making the routine.
I have one question from the remote sensing worksheet, question 6A.
I'll pull it up. কত number?
6A, sir.
The question says that a person is to be investigated using a magnetic resonance MR scanner. Okay. The technique involves is there is a two superimposed magnetic fields. This is the function of these two magnetic fields. Okay. How would you write this answer? This is how I would write this answer. A strong uniform magnetic field is applied to have all the hydrogen nuclei within the patient's body undergo precision. এটুকু লিখলে হবে, but if you, I would appreciate if you write a bit more, undergo precision at the same, what is the name of this frequency? এটা যদি কি frequency বলে?
Lamor.
Yeah, at the same Lamar frequency. Then এটা হচ্ছে magnetic field আলাপ শেষ. Then you can write in another sentence, the non-uniform magnetic field is applied so that the resultant magnetic field inside the patient's body at different locations are different. Bracket, same within a layer, bracket close. As a result, hydrogen nuclei of a single layer can be detected. বুঝছো কি বলছে?
So could you repeat the part about the weak magnetic field?
Okay, no, not weak,
Not
non-uniform.
non-uniform.
We don't use the term weak. We use the term strong, but we don't use the term weak. Okay, the non-uniform magnetic field is applied so that there are different resultant magnetic field values across layers of the patient's body. Layers slash, you can write cross section as well. Layers slash cross section of the patient's body. This allows the detection of the hydrogen nuclei of those layers because they have different Lamarck frequency of precision than other layers.
Okay, sir.
বুঝছো কি কথাগুলা?
Mainly, yes, sir. One to align all the nuclei, one to make different magnetic fields as to differentiate between Lamarck frequencies.
But same Lamarck frequency across one layer is important. I mean, multiple layers are going to have different Lamarck frequencies, but within one layer, they're all going to have the same Lamarck frequency. I mean, it's not that every individual nuclei will have different Lamarck frequency, not like that. So mentioning the idea of layer is pretty important. Do you understand my point?
So do we need to talk about the production of radio waves?
No, that would, no, that is not necessary. How that detection is done, that is not necessary for this question, no.
Okay, sir.
Okay. Should I see the mark scheme for I can actually see the mark scheme. We have time, so why not? Just to find out what the examiners had to say about this question. Number 6. There are. Oops, sorry. Okay. It says a strong uniform magnetic field either aligns the nuclei or gives rise to Lamarck frequency in the radio frequency region. Okay. Apparently in the radio frequency region is an underlying information, so you must give this thing to score that mark. I did not know this, but now you should know. Bucho.
Ji, sir.
Then it says non-uniform magnetic field either enables nuclei to be located or changes the Lamarck frequency, Lamarck or resonant frequency across different layers. Yeah, I think it makes sense. What is on the examiner's report? It says there are many well-explained solutions for both part 1 and part 2. Okay, the examiners were happy. No. A. Most cases did refer to a strong non-uniform magnetic field and a calibrated non-uniform. Most cases did refer to a strong uniform magnetic field and a calibrated non-uniform magnetic field. However, the purpose of these two fields was not always made clear. Okay, typical problem. Kids know that what is inside, but cannot express what is inside. বুঝছো?
Yes, sir.
জি স্যার।
আজকে এইটুক থাক, আমি তোমাদের রুটিনটা বানাবো। রুটিন বানানোর আগে তোমাদের আগে ইউটিউব লেকচারগুলো আপলোড দিয়েছি, তারপর তোমাদের রুটিন বানায় তোমাদের রুটিন শেয়ার করতেছি। ওকে, কে যেন আরেকটা চ্যাটে যেন আরেকটা কি লিখছে, সামিহা gave me a problem. Okay, wait, this is the last problem that we're gonna do. Not sure if it's possible. I'll try. Imagine 41 18 2b2. Imagine 14 is 14.
Sir, Majun 18 বলেছে মনে হয়।
Oh, sorry. May June 18, 41. To be 2. Let's go to 2 first. Okay, a metal plate is made to vibrate vertically by means of an oscillator as shown in figure 2.1. Direction of oscillation vertical sand plate. Some sand is sprinkled onto the plate. The variation is distribution of y of the acceleration a of the sand particle is shown in figure 2.2. So acceleration versus displacement. Is the figure to show how it can be used in sand generation of motion. As it is the basic question of the frequency of oscillation of the sand. Oh, this is pretty simple. A equals to minus omega square x, right, Samiha? A equals to.
আমি 2b2 বলছি
Oh, sorry. The amplitude of the concentration of the plate is gradually increased beyond 8 millimeter. Okay. The frequency is constant. At one amplitude, the sand is seen to lose contact with the plate. For that plate, when the sand first loses the contact with the plate, see the position of the plate. Definitely above, I mean, above the equilibrium position. Calculate the amplitude of oscillation. Okay. So here's the deal. The loose contact thing will only happen when the sand particle will use all of its weight to maintain SHM. এই কথাটা properly বুঝো. I'll say it again. The loose contact thing will only happen when the sand particle uses all of its weight to maintain SHM. Because at that point, it doesn't have any more force to exert on the plate and the loose contact happen. Does this sentence make sense? তুমি কি কিছু শুনছো কি বলছি?
স্যার প্রবলেম না আপনি নেক্সট ক্লাসে বুঝান স্যার
আচ্ছা, I'm really sorry. My kid is getting agitated.
A is equal to 9.81 করে তারপর করব না স্যার?
হ্যাঁ, A is equal to 9.81 থেকে ওখান থেকে গ্রাফ ওখান থেকে হিসাব করে বাই করা যাবে। আমি নেক্সট ক্লাসে দেখাবো, সমস্যা নাই, ঠিক আছে? তুমি এই প্রবলেমটা একটু লিখে রাখো, নেক্সট ক্লাসে আবার দিও। ওকে, আচ্ছা পোলাপান, খোদা হাফেজ। I have to go and I'm going now. Thank you. Allah Hafiz.
Bye bye, sir.
Bye bye.